Hello, Dr. E-Blox here with the E-Blox project of the day. Today, folks, we're going to talk about transistors and how transistors work. But before we get there, just one reminder, please stay at home as much as possible over the next several weeks. The whole reason we're doing these videos is to provide e-learning material for our teachers, homeschoolers, and parents so you can teach the fundamentals of STEM and STEAM through E-Blox while safely from the home. Now, if you have E-Blox at your house, then we encourage you to join in the Building and Learning Fund. And if you're looking to get E-Blox, there are two ways you can do it. One, through our website at www.myeblox.com. That's www.myeblox.com. Or contact your local toy store. You can either call them, email them, look at their website. You can buy our products directly from your local toy store and we'll ship them directly to your house so you never need to leave the home. All right, with that, let's get to the project of the day. We talked on Monday about how we're working towards building an induction spinner, like shown here, okay? And we talked about reed switches, which is going to be a particular important part of that. Today, another important part of it is the transistor. If you have the circuit blocks 395 or 800 sets, you have transistors in there, and they look like this. This one's the NPN transistor. It's number 50, and it's yellow. And you'll see that it has 3 connection points on it. Okay, so it's a little more complex than a lot of the other parts that only have 2. The connection points are labeled C for collector, B for base, and E for emitter. Okay, now even though it's a more complex device, it actually has a pretty simple function. The 2 primary uses for the transistor is one, that it can operate like a switch, okay, where if you let a little bit of current into this base, then it opens the door for current to flow from the collector to the emitter. But if no current goes in there, then no current can flow between the collector and emitter. And then the other thing that it can do is it can act like an amplifier, because when you set this up in the right operating range, then the current that comes in here can be approximately linear with the current that flows from the collector to the emitter. Okay, so we can but the current here will be much greater than what comes into the base. So it actually amplifies the current, okay? So let's take a look at this and how it works. I'm gonna put it in a circuit here. This is our battery, here's our transistor. We're gonna put in this little LED heart from the emitter to the ground of the battery, and then we're going to connect the 4.5 volts from the battery to the collector, okay? So now, this is showing that no current is able to flow from the collector to the emitter when there's no current going in the base, because I got nothing set up to the base, and so the heart is not on. But now let's try putting some current into the base. Look at that. When I let current flow into the base, current can flow from the collector to the emitter, and that's what makes the heart light, okay? Now, you're probably asking the question, where does that current that flows into the base go? Well, it does actually flow out the emitter and through the heart too. So now you're probably saying, well, maybe all of it's flowing through there and nothing's going from the collector to the emitter. Well, I thought about that, okay? So I'm gonna demonstrate to you that a little bit of current in here can create a lot of current through the collector to the emitter. I'm going to do that using another heart. You can use the star in your other sets, okay? But if I put this heart in here, now look at this. This heart is lit up, which means there is current flowing from the collector to the emitter, okay? And that means that there must be current going into the base. But the current going into the base is so low, it can't even light this heart. That demonstrates that only a little bit of current into the base can allow a lot more current to flow from the collector to the emitter. Okay, amplifying the signal. So that's pretty cool. That's how transistors work. Now, what are some applications of this? Because we say it acts like a switch. Well, we talked about switches last time. And why not just use a switch, right? Well, let's think about some applications. What about the fire alarm in your house? Okay, you don't want to have to push a button to make the alarm go off. You want it to go off when a fire starts, right? Well, the way a fire alarm works is there's a device in there called a thermistor. Okay, it acts like a resistor that has a huge amount of resistance when it's at normal temperature. So it acts kind of like an open circuit like this, where there's, it's connected to the base, but the alarm is not on. But then when it gets hot, it actually reduces its resistance, current flows through it, and that goes into a transistor that makes the alarm go off. So there's an example of where you want a switch that's just based on the heat in the room and not actually pushing a button. And that's what transistors can be used for as a switch. Now, how about amplifier applications? Well, we saw one of those when we did the FM radio set, okay, where the FM radio output had a very low current, and then we had to put in an amplifier to make it much louder. There are transistors in there that amplify the signal. And you'll see that in other devices, like when you plug your iPhone into a speaker set that makes it much louder. Those are amplifying it and using transistors. So that's cool. We learned about how the transistor works and how it acts as a switch and as an amplifier. By the way, you know what you get when you cross a dog with an amplifier? A subwoofer. Okay, I had to get in one for the day. But that's cool. We learned about transistors. We learned about some of their applications. We're going to be using that on Friday to finally build our induction spinner. Until then, stay safe, but continue learning with E-Blox.